Grüezi and welcome to the webinar about the WM-MMA series, the new mobile measuring arms from Wenzel. I'm Mark Fuhrer and I'm responsible at Wenzel Metromek AG for the distribution of all Wenzel products in Switzerland and Liechtenstein. This webinar offers the possibility to place any questions via the chat function. We are happy to answer this question directly or as quick as possible. Don't forget that after this webinar we will still be there for you at our virtual exhibition stand. Now a few words about Wenzel. The Wenzel Group is one of the leading manufacturers of innovative measurement technology solutions. The success of the largest family-run company in the industry is based on German quality technology, flexibility and strong partnerships. We here in Chur have been working in software development in the field of measurement technology for over 40 years. We are pleased to be able to present the new WM-MMA product range to you today. These mobile measuring arms complement our versatile product portfolio and offer you new possibilities in metrology. A mobile measuring arm from Wenzel is ideal next to existing Wenzel products or as an entry into 3D coordinate measuring technology. Now I will explain some hardware of this mobile measuring arm WM-MMA 2.5. The 2.5 stands for the entire measuring range, which is a diameter. So then it's from the center of the arm to the stylus 1.25 meters. The Wenzel measuring arms are available in size from 2 meters up to 4.5 diameter range. The Wenzel measuring arms are all equipped with 7 axes and start with an accuracy of 22 microns. You find 2 axes here, 2 axes here, 2 axes here, and the last close to trigger here. The Wenzel measuring arms are temperature compensated and run directly in your production environment. This connecting to a laptop with USB, Wi-Fi or Ethernet. Due to the existing battery, which is located in the back, can you work without an additional power source and that over a long period. Because of the lightweight construction, you can move the arm with only one person at any time and put back into operation. There are various mounting options such as a tripod, so you can see here, or magnetic plates or fixes for a table mounting directly, like this. The arm finds place in the receiving area or direct in production line. Just put it where you need it. The Wenzel measuring arms are delivered with a fixed tactile probe with a diameter of 6 mm. Optionally, there is the possibility to equip the arm with an optical sensor like here the WM-MLS from Wenzel. The arm operates with the Wenzel WM Quartis mobile measurement software, which is established on the market for many years. This gives you all options you need for evaluation in accordance with the international standards as ISO or ASME. Why is it worth to get a Wenzel measuring arm for you? Today we find tolerance in form and positions on almost all technical drawings. But even a simple maximum in script circle you can't check with traditional caliber. The Wenzel measuring arm replaced your classic measuring equipment, such as a height gauge, calibers and micrometers. Set up a measuring station with the Wenzel measuring arm and solve all your measuring tasks with just this all-in-one measuring device. Now I show you the arm in its practical application with the WM Quartis mobile. I now start the arm over the power button on the front side. The arm is connected to my computer with an USB cable, in this case to a laptop. After switching on the measuring arm, I start the measuring software WM Quartis mobile. When starting, I'm asked to initialize all 7 axes. The green traffic light on the computer shows the successful initialization of the axes. I move all the axes. When all 7 axes are initialized, the arm is ready for use. We now want to measure the following measurement task on the cube together tactile. We have a characteristic 1. This is a diameter 12 mm plus minus 0.1 mm. Then the feature 2, the distance between the 2 boreholes of 50 mm plus minus 0.1 mm. And lastly, the feature 3 with a radius 6 mm plus minus 0.1 mm. At the beginning, we measure the top plane, which is the base for the circles. To do this, I select the plane in Quartis in the Measure tab and mark the corresponding plane on the cat. This is colored blue. Now I measure this top plane with the points. To get points, I pull the trigger. For complete the element, I press and hold the trigger while measuring the last point. I measure the first point, second one, third one, and the last one. Now I measure the 2 circles as shown in the drawing. To do this, as with the plane, I select the appropriate circles in the software, measure circle. Now I can measure the circles with the measuring arm. I measure the first one with 4 points. And now I measure the second one. So all the necessary elements for my measuring task are measured, and I start with the evaluation. To do this, I go to the Features tab and start with my first characteristic 1, the diameter of the circle. I choose size, then I select circle, enter the tolerance, or the software does so according to ISO or ASME if required, and then I click on Evaluate. Now feature 2, the distance between the 2 circles. I click on Distance. I choose the 2 circles and click on Evaluate. The feature 3 is a radius that I evaluate with the function half size. Click on half size, choose the circle and evaluate. In order to present these 3 characteristics in a report, I can generate a report from a preset report template. I go to Quartis, New Report. I choose my 3 characteristics in the graphic, and also in the table, and save the report as a PDF. This was a brief introduction based on a simple measurement task. As already mentioned, At the beginning, the arm also works perfect for evaluating form and position tolerance. Here is another example, which we are measuring together. This time, to get a higher density of points, we will scan the planes tactilely. To capture this by scanning, we switch the probe mode to measuring. We measure the reference plane A. With the function measure plane and select the appropriate plane. We start the measurement and now measure it with the arm on the plane. We start here, push one time the button, and we stop. We do the same with the plane on the side for later evaluation of the perpendicularity. With the function measure plane and select the plane on the side. We start the measure. Stop the measure. So, we have already recorded all elements for this measurement task, and we are going into the evaluation. The evaluation functions are divided into different groups and provided with the respective symbol. Here the form, and here position characteristics. We choose flatness and then select the top plane in order to evaluate according to the drawing. We also activate the partial flatness evaluation, adjust the tolerance and confirm this. In the case of perpendicularity, the tolerated element, the plane on the left, is selected and the plane A is set as the reference. Similar to the first measurement task, we can now generate a report. For this, go on Quartis, then New Report, and choose a template. In the graphic, we highlight the top plane for graphical informations. We save the report as a PDF, as done before. Measuring programs can be executed for recurring work pieces. This means that the user knows exactly which elements need to be measured and also how. The evaluation and report generation takes place automatically in this case. In order to show you the advantages of the optical Wenzel sensors, we exchange the stylus for the WM-MLS 100 sensor. This is easily done with the auto joint connection, which can be released using the tool in the box. Then we put the optical sensors on the arm. This is done with the integrated lock system. And done. The WM-MLS is a line scanner. The WM optical sensors were specially developed for use on the measuring arm from Wenzel. Depending on the sensor, these enable you to record a workpiece with no time, with a really high point density. You can measure with a line width up to 200 millimeters. You can capture the component with an accuracy of 9 microns at the data rate of 600,000 points per second. We now capture an area on our cube with exactly these sensors, MLS 100. I activate the sensor in quartis and then select the surfaces I want to measure on the cat. And then I start the measurement. Now we can measure this area with the sensor. The working distance of the sensors from the surface must be observed. Here we are supported by a green positioning light, which is used for rotation. So we start on the right side, push the button one time, stop on the left side, and we start on the back side. And we will stop on the front side. As you can see now in the quartis mobile, the surfaces are measured with lots of points and can be used for evaluation. As you can see, with these optical Wenzel sensors, many points can be recorded quickly and easily. Large workpieces, such as bodies or also flexible components that do not allow tactile probing, can be measured easily and efficiently. I hope that this webinar gave you a quick insight into the world of Wenzel measuring arms, and you take these new impressions with you. Of course, we are also happy to meet you at our virtual booth after this webinar for personal consultations. However, it is also possible at any time to have our products demonstrated close to your on-site or at our Wenzel facilities. Following to this webinar, we would be happy if you could answer a few questions for us. Thank you in advance for your cooperation. We would also be happy to welcome you to other webinars at our online fairs as guests. Now I have to thank you for your attention and hope to meet you soon face to face. A good fair and stay healthy. Greetings from Kur. Thank you.